So this was the first one we looked at, and I kind of did this one as I filled in the answer. Again, when you're doing the product rule, you're taking the derivative. It's the first one, which is just x to the third, times this derivative of the second, plus the derivative of the first, times whatever the second is. Again, this answer should be equivalent if we would have expanded, just distributed our original function and said x to the 4/3. When you multiply like bases, you add their exponents. Right, so we distribute it, and now if we take the derivative using the power rule, these things are going to be equivalent. They're going to look different, but they are the same. Again, I'm just multiplying my exponent times my coefficient, then subtracting 1 from the exponent. Multiplying, then subtracting 1 from the exponent. So this is the derivative, which is equivalent to this. They just are in different form. The next one that was using the quotient rule, one I had was 5x over x squared minus 9. To find the derivative of it, we're going to use the quotient rule. So I've said low d high minus high d low all over low squared. So doing that one, I do low, whatever it is, times the derivative of the high, minus high times the derivative of the low, which is just 2x for that one, all over the bottom one squared. So low d high minus the high d low over low squared. Now this one wants us to actually find what the slope was at a particular point at -1. So we would plug in -1 here. If you were to combine like terms, expand, do all that, you'd have a little bit easier problem to deal with when you're inputting a value. But we could just plug in -1, so -1 squared is 1 minus 9 times 5. So 5 times -1 is -5, and 2 times -1 is -2, all over, again, 1 minus 9 squared. So if we do that, so we're evaluating our derivative when x equals -1 to find the slope at x equals -1. So that would be at that point -1, -1/2, like on my problem. I get -8 times 5, which is -40. That turns into a minus 10 over a, so that's a -8 squared, so a positive 64. So I get -50 over 64, which that could probably be reduced some. I know make sure -5 is -40, -5, and a -2. So if I look at 2 going into both of them, that's -25 over -32, or positive 32, sorry. I think that would be it. Looking at my answer, that didn't match up, and so I was curious to why. I wrote the problem down wrong. It's a +9. So I'm going to change all of these to pluses. I just have to fix that part. So again, got to be careful with signs. I am subject to that the same. So I get 10 times 5, and then I still get minus 10 over 10 squared. So I get 50 minus 10, which is 40 over 100, and that would reduce to 2 5/5, which is better. That's what they had as an answer. So again, be careful with your signs and writing the problem down right. Last one that I wanted to look at was the one that had the product rule and the quotient rule. That was my number 9. And x minus 4 over x plus 1. So when doing this one, I see the product of two things. It's this times this. So I'm going to use the product rule. So I'm going to take my first thing and multiply it by the derivative of the second. Well, the second thing, I would have to use the quotient rule. So I would say low d high, which is just 1, minus high times d low, which is just 1, all over the bottom 1 squared. But again, I'm not done, because that was just my first times the derivative of my second. I would still have to add to that the derivative of the first, which is just 1, times the second. So the derivative of this using the product rule is the first times the derivative of the second plus the derivative of the first times the second. So on this one we had to use the product rule and the quotient rule. This one also asked us to find the equation of the line. So I would need to plug in, I think the value they gave us was 0, which is a nice one to use for this little bit longer problem. If I plug in 0 into this, I get 6 times, that's 1 times 1 minus minus negative 4. Again, plugging into 0 right there, I get a 1 on the bottom. And then I'm going to add to that, when I plug in a 0 into these, I just get negative 4. So I get 6 times 5, and then minus 4, which would be 26. So now that I have this slope of 26, when my x value is 0, I use my point slope form to help me out. And so that gives me y minus my y1. Again, they gave me the point 0, negative 24. So y minus y1 equals the slope, which is 26 times x minus x1. So in this case, x minus 0 will just be x. So I have y equals 26x. That's a plus 24 here, but I'm going to subtract it to the other side, and I get 26x minus 24.